Hi everyone, I hope I'm audible. Sorry for the delay, I was just facing some technical issue, but I think it's fine now. So today we are going to introduce ourselves with Unreal C++ on the perspective of game development. So I will be opening a new project here. So this is going to be a C++ project, all right? So let's quickly create. So when you create a new C++ project, so you need a development environment actually along with Unreal Editor. So typically we use two of the mostly used development platforms. One is Visual Studio, another one is going to be Rider. So Visual Studio has been for us since always, but Rider has been there for about a couple of years, and it has been amazing. I use Rider personally for the last few years. I mean, ever since it released, I started using it. That's because of its I mean, when it comes to Unreal, its code compilation, its IntelliSense is really great. So for today's demo, I will be using Rider also, and I will be showing you around. But even if you are not comfortable with any development environment, then I would suggest that you can simply start with Visual Studio. The interface is going to be more or less similar. So if I show some of the configuration in Rider, then the exact same thing is also available in Visual Studio. So that won't be a problem. All right, so I will just wait till my project gets created. Okay, we are inside the Unreal Editor, and also the Rider is also opening where our project is going to be there. So let me quickly show you the folder structure. So I created the folder here, PPP demo project. So this is your folder structure, and all these these are the folders which are temporarily created. And when you create a CPP project, you also have a solution file. This solution file with the extension .cln is used to open your development environment. For example, in our case, it is the Rider. So this is the Rider interface, and the right in the left side, you see the solution explorer. So if I open this CPP demo project inside here, the project is still being loaded. While this is loaded, let me explain the rest of the stuff. So these are pretty much completely temporary files that you can safely delete. Also, these are the files that are created when you are creating a C++ project, and these are also temporary, you can delete. Your binaries folder are the ones where when you are compiling your C++ code, rider is for evaluation. Yes, I had taken rider for. I mean, I had paid for a subscription for 1 month, 1 year. Back in, I mean, I think back in June last year. But ever since then, rider I have been using its evaluation version, so I have not been paying anymore for it. So you have to just simply go to um, manage licenses, and then you can here you can see that it is for evaluation purpose. Subscription is active until February 16, 2024, which is in about 3 days. So I'm not sure once the subscription expires. So I think I can either activate new license, or maybe then I have to go back to that yearly subscription. So if you go to their website, so just 1 minute. If you go to their website, right, JetBrains, uh, here you can get this is the free 30 days trial, and I mean, like me, you may be able to extend your evaluation, and if not, then yeah, you have to check the pricing over here. So for rider, it's usually this $149 for the first year, and then it gets reduced. Like for the second year, it's $119, and then third year almost $89, something like that. Yes. But Visual Studio is completely free, even if you don't use rider. So you will be easily used. I mean, Visual Studio has the exact same interface. Everything is right on place. You get a solution explorer where your class structure is laid out. Then you get the UI exactly like this. And then in the middle is where you are actually writing your code. So I was explaining this binaries folder. So the binaries is where you are actually storing your. I mean, when you are developing code in Rider, then it is being compiled into DLLs, and that DLLs are what actually being used by the Unreal editor to understand the what you have written, understand your functions, and then Unreal executes on that. I mean, Unreal directly does not read your code. It reads from the DLL. So those DLLs are stored in the binaries. So you can delete the binaries as well. But when you are deleting binaries, then you have to again compile your project. And if you are not deleting the binaries, then you can directly double click on the U project and your Unreal will open. So that is the only difference. So if you are, let's say you have created a function, you have created a class, you have created a plugin or any C++ code that you have in your project, and you want to migrate that project into another project, or you want to give the project, you want to zip the project to someone who is not very familiar with C++. So he's not going to open Rider and compile. So in that case, you have to make sure that this binaries folder is there. Otherwise, he will get the error when he is trying to double click and open this, because if he gets the uncompiled version of your code, then he will not be able to open that. So if you're giving your project to someone who does not have access to Writer, or who is not very familiar with compiling or something, I mean, and he shouldn't have to be, because as a programmer, it's your job that you need to ensure that once you compile, you have to keep the binaries. You don't delete the binaries, but the rest of the folders like this are pretty much temporary. There are a lot of mm, files that are generated and stored in the saved folder, and it depends on you. you may or may not delete that. I usually prefer deleting the set folder always. For example, if you are if you are capturing some screenshots, or if you are generating some error logs, if you are creating some staging builds or packaging of, so those all are usually stored in the saved folder. But the most important folders that you should not delete is obviously the content folder, the source folder, and when I will show you how to create a plugin. So when we create a plugin, the plugins folder is also going to be there, which you should not delete. So these are the important folders that you are not going to delete. And so this content, when you have the plugin, then plugins, and then source, and obviously this project file are the ones that you should not delete. Even if you delete the config, it's still going to be fine, but you are losing all the default configuration that you already have set up. So that's pretty much about the folder structure. So once I create a plugin, I will explain the plugin folder structure also. Okay, so here we are inside the, so this is your source folder that a bare minimal amount of code is generated. I mean, this is actually used to make you Unreal understand that this is your C++ project and not a blueprint project. So this is just bare minimal amount of code. You get few of the build.cs, which are actually not C++ but C# file, and these are used for storing some of the configurations that Unreal would need. And so you can see this file structure over here. So for example, when so you can see this CPP demo project editor.target.cs and CPP demo project target.target.cs. So here you can see these lines written type equal to target type.game, because when you are when you are creating an Unreal project, there is an editor version and then a game version. So editor version means what, before you pressing play, whatever is being executed, those are, so all these basic configuration are stored in the respective files. And this build.cs is a important file because it may happen that you are adding some third-party dependencies in your project. You may want to have compatibility with some external libraries or external APIs, and there may not be a solution, and you may want to build one yourself. So in that case, you have to configure those settings inside build.cs before you write the code. So I mean, and also when you are Unreal source code is actually divided into many modules, modules and submodules, plugins. Then you have all these things. So plugins are basically little chunk of code blocks that are serving a specific purpose, and a plugin can have multiple modules, and those modules are also sections of code that serve specific uh, responsibility within the plugin itself. And when you want to use a specific module, specific functions of a specific module in your own class, then you have to mention that in your build.cs. Once we start writing code, we will understand this more. But this build.cs is what usually is going to be very important file for you to configure your project when you are using some external dependencies. Even if you're using some dependencies from other Unreal modules, then also you have to mention that in over here. And how you, so these are the, for example, these are some of the basic modules that contains most of the Unreal's useful classes like code, objects. So these are already configured for you. But if you need some additional module, then you have to write it over here. And so that's about the source folder. Okay, so now we are going to be opening this because I don't quite like that setup. So space, then you can definitely increase the floor size over, increase the size of the floor. Yeah, that's about it. So I will just save this level. And when you want the editor, when you open the editor the next time, if you want this level to open every time you open the editor, then in project settings, you go to maps and mode and you just change this. All right. So now the important thing, now the next thing I'm going to do is create a plugin. So plugins are code that serve a specific purpose, and modules are also blocks of code that are present inside plugin. But a plugin can have many modules like that only. They have multiple plugins and each of directly add everything in your source folder. So whatever classes configuration, I mean whatever code you're writing, you just add as separate classes over here inside your CPP demo project. But I prefer plugins because plugins are not dependent on your project, and if you want to migrate it to another project, you can very easily do that. If you want to sell it to the marketplace, since I have been a marketplace seller for the past 8 years, I mean since September since 2015. So plugins I'm used to writing plugins and I prefer writing plugins that way. But I have seen a lot of people who are not very familiar with plugins and they add everything in the source project. If that works for them that's fine. But for me, I find plugins to be very useful because they are not quite dependent on a project and they can be very easily transferred to any other project and they serve their own specific purpose. So let's create a new plugin. So these are all plugin templates. So I will just explain these templates. Blank plugin is the minimal amount of code that is required for a plugin, similar to this minimal amount of code required for the source to run. So plugin also has a minimal amount of code. Then blueprint library. Then you have so blueprint library is going to contain code. It is going to contain like you have all these editor modes. You have this tools in the details panel. You see all these buttons. So these are part of your editor tools. So whatever things you are seeing, whatever buttons and functionality you're seeing, even you are right clicking and you are bringing this content browser menu. This is also part of your editor code. Okay. Okay, Rishikesh is saying the stream is drop. Actually, I was facing some configuration issue in OBS Studio, so I had to use the YouTube's default stream. So actually, let me change the resolution of the monitor from 4K to 2K and see if it is working better. So I have reduced my resolution. I'm not sure if that is making the stream a little faster. But anyway, let's work with this. So yes, I was mentioning about this editor modes, and if you are, and this is quite advanced, and if if you want to learn about editor extension, then maybe we can set a separate. I can just work with this. So third-party library is for. So I will be using blank. object interaction. Okay, create the plugin. So now you see a now you see an additional plugins folder over here. Even here you see the additional plugins folder added, which is having the same name. All right. So and yeah, inside this plugin folder or inside the object interaction folder, you see again you see binaries intermediate. This binaries is having the exact same purpose that I explained earlier, where anything that your plugin is going to compile, that is going to be your DLLs, and those DLLs are stored in binaries. And if you delete the binaries folder, then you have to recompile it. You cannot give it to anyone else, because then that person has to recompile the code. If you want to directly open from the U project every time you are accessing this code, then there are two things that you need to do. First, you need to ensure that this binaries folder is not deleted. And secondly, in your editor, here you see a lot of configuration. Secondly, you need to ensure that your configurations in development. So I will be explaining what the solution configurations are. So here you see configuration, and here you see target. Target is given as editor, and the configuration is given as development. So shipping, I mean, when you're packaging or shipping your project for the final version of it, and then you definitely can use shipping configuration. It is going to create a very compact, bare minimal amount of compact code with very minimal amount of size, and it is going to remove a lot of unnecessarily functionalities for you, just reducing the size further. And we typically use the shipping configuration for the final package version, but other than that, we either use development or debugging configuration. So when you have development configuration, it means a lot of debugging option. If you are not familiar with debugging, let me explain. When you are facing some issues or errors in your code, there are two kinds of errors. One is the compile errors. If you are making any mistake in writing anything in your code that is having a syntax error, then that part becomes your compile issue, and that is going to be your Unreal editor will not open in that case. You have to fix that issue, and then your Unreal editor is going to open. And then you have a functional error. You may have made a functional or logical mistakes, and then you need to fix that. You are not understanding because there is no compile error. Then you need to debug this line by line to understand what is being happening. And a lot of functionalities and lot of usefulness of the debugging comes into place only when you have the debug configuration enabled. When the debug configuration is disabled, the lot of debugging features are also disabled. I mean, you can still debug, but there may be some scenarios when some of the debugging is not making much of a sense because that particular debug symbols is not available. So when I am actively debugging, then I will use the debug game. And when I'm doing some minimal debug or absolutely no debug, I'm pretty sure that this is what I'm writing. So this is going to be correct. So I just need to uh, run it and you see how it works inside editor. Then I will be using development because a lot of debugging symbols are disabled, so it is obviously faster than using debug game. And development editor also ensure that your plugins or your Unreal project is compiled in a way that can be easily accessible by anyone without having to recompile it. Debug game means that even if you double click this, it will not open the debug game version for you. It will always open the development version for you. Remember that. So when you are double clicking that, the last compiled development version is only going to open. So if you are compiling it and then you have used the debug game, then someone who is not compiling from Visual Studio, someone who is directly opening, that person may say ki these are the features is not available. But you might think that okay, I have already added and in my Unreal it is working, but why it is not working in his case? But that's probably because that person is not using your solution to compile. That person is directly opening, and your solution may have debugging enabled. So last development is only taken into consideration. So make sure that that is happen when you are giving it to someone. Always compile in development and then give it to that person for further testing. Remember that. So in our case also, initially I will keep it development only, because since a lot of symbols are not loaded, it's much faster in that case. All right. So let's understand the plugins folder right now. You have resources which just contain the plugin icon and not very important. So plugin contains this plugin name, and it contains the source folder, and this also contains the plugin name. So what does this mean? This means that this is actually a module. This is your plugin and this is a module, and the plugin and module have exact same name, but that shouldn't be the case. This is just by default. Your plugin may have a different name than your module. So usually if you go to the engine source code and go to the plugins folder, you see a lot of built-in plugins are there. Let me check any of the plugins. So let's check this plugin. So this has AI support module. The module name is different than the plugin name. Plugin name is AI support and module name is AI support module. Let's check this one. So it has two modules. One is HTN Planner, which has the exact same name as the plugin, and one is a HTN Test Suite, which has a different name. So there is no hard rule. I mean, it is up to you what your module name is going to be, but by default, your module name is typically the same as the plugin name. So how do you create a new module? I think if you are using Visual Studio, then you have to do it manually. But I am not sure whether they have the functionalities available right now. But in Rider, it's very easy. So if I go over here, not here, if I go in the plugins and add, you see I can create a plugin directly from here. All right. And if I select this plugin, go add. Okay, not here, but here, I think in the source, yes. You can see I can create another module directly from here. But if this option is not available for you, then the only way to create a module is just create another plugin and then copy the module to this plugin inside the source and then recompile. Because Unreal does not allow you to create a module inside a plugin directly from here, and that has been always the case. I mean, so maybe no one has asked them to do it, so they didn't bother. But in Rider, you can very easily create another module. Or also, most of the times you don't need to use multiple modules in your plugins. All right, so let's understand the classes now. So inside your module, you have the private and the public folders. Okay. So the public folders is going to contain your header files. Header files are always represented by .h, and C++ files are represented by .cpp. So now what are header files and what are the C++ files? We will understand now. So header files is going to contain all your variable function and class declarations. Means if you want to make a class accessible to any other class, any other module, or any other plugin, then the first thing you need to do is create a header file and declare that class in that header file, because any other module or plugin does not know you about your C++ file. That class only knows about your header file. So header file is kind of like your public, which is shared with others, and C++ files are like your private, where you're writing your actual code, which is not accessible to anyone else, and that only the header file, I mean, where the function declarations are going to be there, that is going to be accessible. So if any other class or any other plugin is going to want to call your header files, call a specific function in your header file, then that, I mean, you can simply do that with a function declaration, because without knowing what the function contains, and your C++ file is going to be responsible, because this is always attached to that, this is always associated with the corresponding header file, and your C++ file is going to contain the logic for the function. So once you call the function from an external class, then logic gets executed inside this class. But that doesn't mean the other class is actually knowing what exactly is happening. Okay. I mean, that other class is not able to see through your class. So that is the benefit of having this as separate. So if you declare your class inside the C++ class itself, that becomes a private, and that does not allow anyone else to access that. So that is for easy accessibility. We always have a header class. We always had a header file and a C++ file. Okay. Right. Now, and some and this particular class has the exact same name as your module name, object introduction.h and object introduction.cpp. So you understand these declarations now. Here we add, this is the syntax that we use, include any other class dependency, and that's how we are actually accessing the functionalities from any other class. All right. And this is what are there to ensure, to allow you to write something that is happening exactly when the module is loaded and when the module is unloaded. These are two functions. We will explain what this means in a bit when we are creating our own class. But for now, let's just understand that this is actually a part of the plugin's mandatory class structure. For example, this implement module. This entire line is making the plugin or making the entire Unreal project aware of the existence of this module. And without this line, this entire module is not going to compile at all. So whenever you are creating a new module, new plugin, this is always going to be there. It doesn't have to be exact same name as the module name, but still this will always be there. Okay. And then you have the build.cs, which I explained before, where you are adding all the other external dependent module names. If you don't use any particular module, then you don't have to add it over here. And then you have the .u plugin. Here, any plugin or any modules that you have added in your plugin is going to be defined here in a very specific way. And you also have a lot of configuration settings that you add, like file version name, friendly name. So when you are when someone sees your plugin, they will be able to see this and understand that that these are the information it has. For example, you can have a creator name here, or created by, if you have a website, you can add the website information over here. All right, and then you have documentation, you can add it information over here. If this plugin is inside marketplace, you can have the URL here. So all these are for anyone else to see and understand what what are the other external information associated with that plugin. And if install is false, means by default it's not installed, and if someone is want to install it, then that person has to enable that manually. And if this is set to true, then the plugin will have the a warning symbol that this is experimental version. Same with the beta version also. And can contain content. If it is set to true, then this plugin is going to have the content folder also. Okay. Inside that you can have any UI asset that you want. All right. And if you have multiple modules, then you can just simply add a comma, then add a set a parenthesis, and then write your module name like this. Now, modules have this category, like it has name, which is the object integration name in our case. Type is going to be runtime. It can be also editor. So when a module is a editor module, then all the features, I mean, typically you create an editor module when you are building some editor extensions. For example, I just mentioned that this is a part of your editor extension. If you want to add a button over here or add another additional menu over here, then you are actually creating an editor functionality, and that will not be accessible in the runtime. So a lot of the functions that are present in that feature to make it enable make it work with the editor is not going to work in your compiled version. So to make it, to ensure that you do not get any error when you're packaging or compiling your project, you have to either create an editor module itself, like type editor automatically ensures that this module is not going to be compiled when you are packaging your project, or if your module has some features which is editor only, then you have to mention an if else statement in that. So we will understand how that works in a while. When we are building our class, we will just understand that, because there are going to be few functions inside a class also that is editor specific, and that will not work in the runtime. So you have to ensure that you handle that carefully, otherwise it is going to give error when you're packaging your project. Let's understand object-oriented programming right now. So Unreal has the classes that are accessible directly inside Unreal. That so even these the assets you are seeing, these are actually we call them as U asset because these are available in the content browser. So if you right click and show in Explorer, then you see these are all U asset. U asset is derived from U object with the Unreal asset or U asset. So so below the object comes the actor classes. Anything that you see placed inside our viewport. If you place anything, like for example, let me place this cube. Okay. So this becomes your actor. If you duplicate this, so these are multiple instances of the same actor class, and this is actor class because this can be something that is directly added in the viewport. But I mean, just if you see something, I mean, the U objects, the U assets are actually not directly added in the viewport. When you are dragging it, basically you cannot add it. But what happening over here is you're assigning a material on the floor that is having this texture, which is not same as dragging and accessing the texture directly in the level. So this is not a new asset. This is a material which is also not a new asset, but you can directly drag it over here. And okay. So what? So this actor class is going to be your main class, that is BU. Static mesh actor is an actor that has a static mesh associated with it. Okay. And then comes the components. Like here you can see inside the actor, we have the static mesh component. So components are also U objects, but these are not directly added in the level. So these are not act components because these can be attached to an act, can be created and have a lot of other similar properties. So and you can, even if your actor can be created, deleted, but actor can be it can be moved from one place to another because it can be added in the viewport. So it has these transformation properties. So anything derived from the actor is also going to have the transformation property. For example, this is also a static with having the same transformation property as the actor. But there is no such thing as transformation property for this texture cube. It is just an U asset. It can be either created or it can be deleted or it can be duplicated. All right, stuff like that. Any class that is accessible to Unreal Editor, if your class is not a new object, that means that class is only there to serve some specific purpose inside your C++, but not having directly anything to do with the Unreal Editor. All right. So we are going to build our first actor class. For that, I will go to Tools, create a new C++ class. Okay. Here you see you have this actor class. So you get an option. So none means you are creating basically an empty class. Okay. And then you have character, pawn. So we will explain them later. But yeah, this is the actor component I was explaining, which can be attached to any actor. But this is the class I'm interested in, actor class. I will just click next. So when you create it inside your public folder and your C++ is going to be created inside your private folder, when you choose class type to private, then both your header and C++ are going to be created inside your private folder. Okay. Here, I need to have an actor name. Let me name it as introductory. Right. So let's close all tabs and open it from here. Oh, I think I mistakenly added this over here. So let me just quickly delete this. I will just do it one more time. So I'll just delete it from here. Also from here. Let me just do it another time. And one more time. So here. Yeah. What I forgot to do is choosing the module. So there are actually two modules. The CPP demo project is your source code module. It is not a part of plugin, but this object interactions is a plugin module. If your plugin has multiple modules, then all the module name individually will appear over here. Okay, now I will name it as demo. Oh, anyway, I'll just add an S over here. Instructions. Okay, so it is going to be public. Create. Okay, now it has appeared over here inside your plugin folder. Inside public, you have the .h, and inside private, you have .cpp. And you already see some basic lines of code already added for you. Let me explain. So this U class syntax is going to mean that this is a part of your Unreal class and is going to be accessible to the Unreal editor. Okay. And and this means that this class is actually derived from your actor class, and an actor is always represented with an A in front of it. So whenever you're creating an actor class with a name, so you will always get a name of A ahead of it. So even this is called as A actor, not just actor. Okay, and when you are building an U object, that will be always starting from U. So objects which are not an actor are going to be starting from U. All right. So that's how the classes are defined. And when you have structures, I will explain what structures are, but usually they are referred to as F. So they have a very defined types of naming convention that we will understand later. But for now, let's understand this. So yeah, this is also important when you are creating an actor class, then a temporary file is also generated for you, and that is usually present inside your, I think it is present inside your intermediate. So your intermediate has a lot of unnecessary files that are going to be generated. So okay, your source code also has the okay, lot of folders unnecessarily generated over here. So this generated.h is a temporary file which is generated automatically by the your development editor when a class is being compiled, and for that whenever you're declaring a U class you also have to use this, otherwise your Unreal will think that this is not an Unreal class. So generated body is important kind of, and also you need to mention that, otherwise it is going to give compile error, because like I mentioned, this is going to be the last statement of your include, and any other dependencies that you are having, you are adding them over here. Okay, so we are now going to look into this, the public. So these are referring that there are three stages of privacy. One is a public, one is a protected, and one is private. So I mentioned the child structure hierarchy. You have your parent class, then your child classes are derived from your parent class, and that becomes a part of your object-oriented programming. Even if you learn C++ or Java or C Sharp, anywhere you learn, nowadays it is always object-oriented programming with the inheritance and all. Okay, so public means your anything variable or any function that you're defining inside here are going to be accessible everywhere else, means in other classes as well. Protected means those functions are only be accessible by your child actors but not by anyone else. And when you use private, that is going to mean this function classes or any function or variable that you declare inside this, they are going to be accessible only by this particular class and nowhere else. Okay, fair enough. So now whatever we are building that I want to access inside the Unreal Editor, we have to add an additional syntax called uProperty. So let's say I want a variable. I want to declare a variable and I want that variable to be accessible inside the Unreal Editor. So first I write the variable name. Let's say it's a float variable. Okay, the float my variable. I add a variable name. But now inside the uProperty, I have to declare some syntax like edit anywhere, or it can be visible anywhere or visible defaults only. Each of them has specific meaning associated, edit anywhere. And then we have blueprint, blueprint read only or blueprint read write. Okay, so you can write something like edit anywhere, blueprint read, read write, and then you can specify category, my test class. Okay, and this makes this function available outside the inside the editor also. Okay, and then you can change its value from the editor, and that variable, that value gets used in your class whenever you're building something. That value gets used over here. Okay, so I have some starter content. Let me just instead of explaining like this, let me explain you through demonstration. So we are going to build something meaningful or interesting over here. So let's add a content feature, content pack. Let's add this third person. I can also add a C++ version of third person, but I'm not doing that right now because I mean we will set up some. We will understand how character works in C++ in future sessions. For now, let's just do with the blueprint one. You have this blueprint. Then you have the inputs and everything set up for the third person. All right. So I have this starter content with some of the assets. So what I want an interactable door. Okay. If I go near the door, I want that door to open. All right. So here, let me create a component over here. Component means when you are defined a actor, I said every actor has a component under this. So this static mesh actor has static mesh component, and you can define components inside your C++ classes. So control property edit anywhere are typically not used for components because I mean when it comes to edit anywhere, I will just tell you what it means. So here you have the details panel. So I am able to modify in settings inside the detail panel. So this becomes edit anywhere. Edit anywhere means I can edit it from here. Okay. So visible anywhere means I can see it, but I cannot edit it from here. Then you have edit defaults only. It means I can edit it inside the blueprint of this class, but I cannot edit it inside the viewport. And then you have visible anywhere and visible defaults only. Visible anywhere means it is going to be visible across your blueprint and also in your details panel over here. And visible defaults only is going to mean that it is going to be accessible visible only inside your blueprint. So let's specify visible defaults only for now. Okay. And because the properties of my static mesh component, I want to only access that inside blueprint, but not inside the viewport. Have, let's say, blueprint read write. It means it can be readable and it can also be writable inside the blueprint. Then I can set its by category. I can just simply add a defaults, or I can add a category name over here. Then I want a root component that is going to be the absolute root for your for your actor. So root components, every actor automatically has a root component, but you can specify your own root component. So there are two main types of components that we usually use for defining routes, and one is the screen component, and another is the billboard component. Billboard component. The difference between scene component and billboard component is scene component does not have any visual representation, and billboard component can have a visual representation if you want to have a custom icon for your blueprint so that people can know that this blueprint means it is actually this doing this functionality. So you may have to you may want to specify that with a custom sprite text 2D texture icon that you may build externally and then import it in Unreal. So then you can use billboard component. Let me just show you how that works. Like I will use billboard component, root billboard. Okay. Then I also want to have a static mesh component over here. So I will just call this use static mesh component. Main mesh or just simply mesh component. Okay. So now this actor is going to have this static mesh component and it's going to have this billboard component. So I declare the variable in my header. Now I have to define them inside my C++. So if you do that, then it is going to be like null pointer, but I don't want that. Let me just save some time and go to GPT. You will see how easy it is to do it. Over here, I'll just copy this function and I will write CPP for this. Let's see what it gives. So it is creating it is defining the variable for me so that I don't have to do it. Otherwise, I would have to write this. And now I can simply just copy over this data and add it over here. So getting this error because this is actually this needs an include also components, billboard components. But I want to add that not here, but rather inside the header because I have defined it in header also. All right. It has also given the name for it, and then root component is root billboard, means it's going to be the absolute root. And then mesh component is your static mesh component, and it has already set up attachment for this. So now I can ask it. I can tell it that I want to have a static mesh added that I can modify from the editor also. No, not like this. Anyway, I'll just meanwhile write that. So this is your static mesh component, but this is not same as the static mesh itself. I mean, this is your component, but the associated static mesh is going to be this cube. This cube is not the same as the cube component. This cube component, this static mesh component is usually an empty component, but when you assign this with the static mesh, then that becomes the cube. All right. If you drag it directly in the level, then this becomes the static mesh actor. And then this actor is going to contain the static mesh component, and this component is going to be this cube. But this is not an actor. This is directly not draggable. But Unreal has made the functionalities around it so that it is automatically creating an actor class, that is a class with a static mesh component inside it, and it is just setting this static mesh value with the as a reference to this static mesh component. And we are going to do something very similar over here, like this. New property, edit anywhere. Okay, this becomes an editable mesh. And I will just now add it like this, mesh component, that's static mesh. But I cannot add it over here just like that. I need to have another function called, so these are begin play and tick. I need something like on construction. Just add this. Now I will explain what these are. Okay. So your virtual void override, what does this mean? I have not explained yet, so I will just do that now. So begin play is a your virtual void over means that this class can be this function can be redefined in your child classes, and override means this is actually a parent class. This function is actually defined in the parent class, and it is being overridden in the child class. That is a part of your object oriented, and we call it method overriding. You can just look up in the Google. Okay. There are two concepts. One is method overloading, when the same function can have different parameter values or different return values, and then there is method overriding, when a child class can override the functionalities of a parent class. So if you go to the actor class and if you look for this begin play, yeah, you get this virtual void begin play. It is defined like this only. So when you want to define a function in a way that can be overwritten in a child function, then you define it like this. And when you already have a parent function defined and you want to override in the child class, so in the child class you are defining like this. Same goes with construction. So these all have specific meaning. So this begin play is the function that is already predefined inside the Unreal code, and this gets called when the play begins. So anything that you want to add immediately when the gameplay has begun, then you add it inside the begin play over here. So this super begin play means whatever functionalities this begin play already has in its parent class is going to be called, and on top of that you can do your own stuff. If you delete that, it means that whatever functionality the parent class has is not going to get called. All right. So, and over here for the on construction, this on construction, if you are familiar with blueprints, then you might have better idea what construction scripts are. So construction scripts in the blueprint, if you have not seen that, let me explain. Those are any functionality that you are building inside your Unreal editor before the play begins. Whatever you want to do, let's say you're moving this but you are not. So that becomes a part of your own construction. So if you are building a tool, typically what I do, I build a lot of procedural generated tools generator. So I can just add the link over here as well. So you can just see that I have developed it completely using blueprints, and I have also used the construction script for that. So a construction script is, I have added the link over there. So a construction script is where you are adding functionalities that you want accessible before the play is beginning. And begin play is the functionality that is where you are adding functionalities that you want to access or that you want to execute after the play is beginning. All right. Okay. So now what I will do over here, I will call this mesh component, and then I will do set static mesh, and over here I will add this table mesh, or I will just name this as something source mesh. Okay, it's better, source mesh. Okay. So what happens right now is every time you are changing the property of the mesh within the Unreal editor, this construction is going to get executed, and this is going to be automatically reset. So here you have to define the if else statement, something like that. I forgot the syntax, so let me go to grab the on construction if you editor statement. I think the if with editor, not like this, but anyway, this is the syntax I was looking for. I will just add it over here. So I mentioned earlier about the .u plugin where this type is going to be runtime. So when the type is runtime, this means this is going to be accessible in the package version also. But on construction is not available in the package version. So when you not do this, then it is going to throw error. So when you're doing it like this, you have to ensure that on construction is wrapped with the editor. Any editor functionalities, there are other functionalities also, like there is something else that I use a lot. It's going to be post edit change property. And this is also a part of the editor. So you cannot just do that inside header. You have to also do it over here. Then you do an index. Okay, so this what is the difference between this and this? So post edit change property, whenever a given property is actually changed, so you can specify that only that property has changed. So you can basically do the function specific to that property change inside that. So that is a part of post-edit change property, and this feature is not available in the blueprint. So let me show you how it works exactly. So let me save myself some time and will make GPT do the hard work. Let the post-edit property change the uh, static image instead. Okay, this is what I wanted. I will just simply add it over here. So I have renamed it actually source mesh. Okay. So what is the difference between this and this? So whenever you are calling something in on construction, then all the functionalities, inter-function functions, everything is going to be executed at once. But here you can actually specify only a chunk of function to be executed, and that prevents your editor to slow down when you are making too many changes at once. By specifying this, you can actually prevent some functionality to be executed repeatedly, and that actually helps you uh, prevent slowing down the editor when you are actually changing the parameters a lot. Because whenever a parameter is being changed, whenever this is being changed, if you are adding the respective logic in the construction script, then the entire construction script is going to get executed. No, and you cannot specify it like that. But I prefer it doing like that because for really complex classes and functionality, it gets really messed up, and the construction script may slow down. And it will not slow down your game obviously, but it will still slow down your editor performance just when you are actually making any changes. Otherwise, yeah, I mean it's fine. I mean, whether you are making any changes or you are actually moving around, even when you're doing this, then also your construction script gets called, and it does not make any sense for you to call this function when you are simply moving this around. So I will just delete it. I like it like this way. Okay. So let me see how this works. This is a very basic demonstration actually. So I will just compile this. And now let me create a folder called blueprint. So I'm going to add a blueprint class. Instead of one of these, I will just search for my class. What was the name? Interactions demo. Actually, there is the class that I previously accidentally created in the source, that is also coming up here. So I will just choose this one, interactions demo. Okay, select. So D3. I want to make it door interaction. I will just add it. Here is your billboard. And if you open this blueprint, you can now choose your billboard, and you can go over here and you can add any sprite, or even if you have a custom sprite, you can add that over here. If you have anything built custom for this, you can simply add it. So it is recognizable that this is your blueprint. All right. So now that we have this set up, you can see the source mesh properties showing up here. You can simply add any mesh. Let me just select some static mesh from here. Just add this door. You can see this door mesh has been generated now. Just drag this down. Right. You switch to third-person game mode. Then you have the character. It doesn't have any collision, I think. Add some collision over here. Add box simplified collision. Okay. Now this door can be opened and closed like this. So let me add a door frame first over here. on top of this. Now it looks good. Click down. So that can be opened like that. If it is open, let me see if I can pass through. Yes, now I can pass through. Okay. So now what I want to do, I want to add a trigger volume. So let me go over here, again copy the code, add a box trigger volume that will be triggered when the player is inside it. So I need a box component for that. So here you go. This is the mesh component I'm looking for. Here also I have to define components box component.h. And here I will call this function on overlap begin and on overlap end. I also have to define this like this. I will explain you what this means actually. So here I am basically defining this similarly. I am attaching this with the root component, and I am initialing an extent of the box. I mean, its initial size is going to be 100. Collision profile name. I don't think I need that. On overlap begin and on overlap end are going to be a dynamic function. So this is actually delegate events, which is quite an advanced topic. You can define your own delegates also, but there are some delegates. If I press F12, you can see this F component begin overlap signature. It's a part of primitive component Unreal source class. If I press F12 further, where it is here, declare dynamic multicast sparse delegate 6 params. So this is a typical example of how a delegate is being declared. Delegates are actually events that can be triggered when something happens. It can be any event at any part. So you can trigger your own delegates also. When something happens, you can simply trigger the delegate, and then you can have multiple bindings to the delegates with multiple functions. So whenever there is a binding associated with delegates, so the functions or underlying logic associated with the delegates is going to get executed through that binding. So you have to trigger the delegate, you have to call the delegate, and you have to bind the delegate. Okay, so here I am binding the delegate by calling the function add dynamic, and this is the function that is being defined over here. I'm going to define it now. So via this void, I will ask it to implement, and I also will just add it over here. So now what I did, I bound the delegate with the correct executed function. So whenever the trigger box, whenever this box component, when the player is inside the box component, this is going to get called. Hopefully, we will just see if this actually works or not. So now first thing it's doing, it is checking if the character is a player character. I will not, I mean, okay. So let's do that. I don't need to print and debug message. I just see if clear character. Yeah, I have to again add an include. This is including game framework characters.h. So if this player character is overlapped, then okay, let me just check if the math if it is actually working by debug by calling this function. So this function is going to print a debug message on screen. Okay, having a green color. So key basically means if there are multiple debug message, then this will not be overridden by other. It will be independent. But if the key is more than 0, or if the key is 0 or more than 0, then in any other message having the same key is actually going to overlap with this. It's actually going to override this. So time to display for 5 seconds, green color, and this is the message that is going to get displayed. They have entered the trigger volume. And then on the overlap has exited, then I will just simply add this. Their character. They have exited the trigger volume. Okay. Let's see if this works. Let's compile. So my volume box has been generated. Actually, the door is not exactly in the center of the billboard. So let me just fix that quickly. Mesh component, set relative location I will set to something like, so this is actually your y-axis. So it will be, it is going to be a vector 0, 0. No, 0, 50, 0. This will not work over here because this gets executed at the this gets executed when the editor is opening. So I have to close this and reopen actually. So, okay, anyway, what I will do, I will just, instead of doing this, I will just add a variable over here, a vector relative offset, or maybe a transform, relative transform. So this uh, this is a variable that holds the translation, rotation, as well as the scale property of an actor. So just use this instead. and the post-static property else if relative transform, sorry, relative transform, then that relative transform is going to be this. Okay. So I got this over here. Now if you change the y, it is going to go over here. I will just add y to 50 and let's control. Now it is exactly in the center of the box. Now let's see overlap. I think it's not quite working. Add this over here. Let's increase the box extension actually. Let's add another variable. A vector box figure size, and initial size can be like 200 by 200 by 100. Okay. Figure volume. This time let me add it over here. Let box extend figure size. Let's see if this works. Okay, so now you can just change the extent over here. No, not from here. From here, trigger size. You can play along with this. Okay. Now if you check, it is on overlap between. I think it is because of the collision profiling. Just I will open the blueprint. Here, yes, collision presets is triggered. Let me switch this to overlap all. Now let's see if it works. Component begin overlap. Let me add the and check if this works. Oh, now both of them worked. Change. In the end overlap. Let me just again add this and see how this is working. And then component end overlap. Let me add a print string over here and see. Yes. This is very weird. Now both of them are working. Yeah, now you can see working for both of these. When the player is going towards it, then I want the door rotation change. Like this. 90. So what I will do when the player is on the trigger, then I want to change the position of the static mesh smoothly from 0 to 90 and vice versa when player exited. So yes, I can add a variable definitely over here. So let me add a variable. This variable I don't want to be accessible inside Unreal, so I can use U property. Having U property means this variable will not be garbage collected abruptly. Otherwise, sometimes what happens, Unreal abruptly can garbage collect your variable. But usually, I think for Boolean variable, it's going to be fine. That is only relevant for the complex like this pointers kind of thing. But even then, let's do it like this. So a U property also going to mean that whenever you are exiting your Unreal level, this is going to get stored. I don't want that, so I will just remove the U property for now. And I will add a private over here. So bool. Now it is going to be bool b uh, is player inside. By default, it will be false, right? So when this is happening, this is going to be true. And over here, this is going to be false. And now in the tick event, so tick is your event that gets called at every frame of your for the duration of your game. So whenever you are whenever you want to add some functionality that is having a repeated execution, you typically do that in the tick. So I will just simply copy this over here. Inside target rotation inside is going to be 90, otherwise it's going to be 0, and interrupt speed is going to be 5. So 90, 0. Oh, better. If it's going to be the in pitch is going to be 0, yaw is going to be 90, and roll is going to be 0. In for here, entire thing is going to be 0. So this is your rotation. This is your rotation. So your is 0 over here, 90. If the player is inside, then it is going to be the target rotation is going to be 90. If the player is outside, the target rotation is going to be 0. So current rotation is going to be the current rotation of your mesh. We get that by getting this component rotation function for your mesh. New rotation is going to be the interrupt. So what this does, this is going to gradually interpolate your current rotation to your target rotation over the time frame of your, this is delta time, means your delta, the fraction of the time that has been passed in the last frame. So, and the interrupt speed means 5. Interrupt speed is 5 means it's going to be pretty fast. And interrupt speed is going to be 1 means it is going to interrupt very slowly. So let's see how this works. Let's compile this. It's finished, and then I will just, the door has opened and door has closed. Door has opened and effective to demonstrate the capabilities of Unreal C++. Now you can also add an input component. Let me also show you how it works. So now this is an alternate approach where I am not directly opening the door. I'm only opening the door when some the function is being called. So instead of this, I will just use toggle rotation over here also. Now I will add an additional function. So let me explain the U function right now, which I haven't explained. So U function means that this function will be typically accessible to the blueprint via this blueprint callable method. Okay. And here we are defining it U function, but we have not added blueprint callable. We have to define this U function because this is actually a bindable property, and this requires this to be associated with U function only, but we are not making it blueprint callable. But this will be blueprint callable. It means that this function can be called from blueprint. So now we can define this. So when toggle rotation is called, so this rotation value is just going to get toggled. Okay. And in the tick, I can now, instead of this, instead of the overlap, I can simply use this thing, toggle rotation. Target rotation inside is going to be 90, outside is going to be 0, and rotation is meter of speed. Let's decrease it to like 3. Okay, I need this actually. Like that, toggle rotation. Yes. Perfect, right? So now the rotation is going to get toggled based on this, but I also want to only execute this when it is inside it. So I will keep the previous variable as well. If layer inside, okay, and this will be added back. This is 2 equal to false. I also don't want the debug message anymore, so I will just turn this off. This 2 and this false, and Now I will just do a check. In my tick event, if player is inside, then only this will work. Okay, it's compiled. Now I will add an input function over here, but before that, I need to ensure that this receives an input from us. For that, I have to go to auto receive input and set this to player 0. So here I have it. Let me see if this works. If E is pressed, let me print a message first. Yes. When E is pressed, the logic is working. Now I will just do a toggle rotation. Made some error in the logic, so when I am calling the function, you have to check this also. Yes. And then I don't need to do this because I am already doing the check. Let me see if it works. Bring inside near. Yes. Right. See, it's working. I'm going outside. It's no longer working. So when I'm pressing E repeatedly, then it's opening and it's also closing immediately. So I think I will have to continue this in the next session where we can build some custom character input. We can set up a metahuman character in C++, and we will understand how character class can be C++, and how we can set up input system that work with C++, how you can set up metahuman that work with C++, and also how you can set up